Okay, hello everybody. Welcome to today's lesson. On today's notes, we're going to talk about 12.6, and the shape we're going to hit that we haven't seen yet in chapter 12 are spheres. Spheres are basically three-dimensional circles. We're going to cover the surface area and the volume of a sphere today. There is a formula for each. So here we go. All right, some terms first. A hemisphere is a half of a sphere. Okay, so we'll be taking the volume and surface areas of hemispheres as well, which is half of a sphere, kind of like a bowl or a dome shape, I guess. A sphere, a full sphere, kind of looks like this. What they'll do is they'll just have a normal circle, and then to create the illusion of three dimensions or depth, we'll kind of have a circle drawn in the middle, front side solid, back side dotted, and a lot of times they'll draw like a radius coming out of the center, or maybe a diameter going all the way across. So spheres do have radii and diameters, just like normal circles do. Another term, great circle. The great circle is just the two-dimensional normal flat circle that is slicing through the center of a sphere, okay? So like this right here, see that two-dimensional circle? That would be the great circle, okay? So the great circle is just a normal two-dimensional circle in the center of a sphere, okay? Or through the middle. It doesn't have to go side to side, left to right, or horizontal. It could be going up and down or sideways, you know. Now the great circle is a normal circle. So you can discuss the circumference of it or the area. So keep in mind, remember your circumference formula is pi times d. An area of a regular circle, pi r squared. Okay, let's go and look at the formulas. The surface area of a sphere is 4 pi r squared. So you'll see pi r squared like a normal circle area, and then you just times it by 4. So 4 pi r squared, surface area of a sphere. The volume formula is right here. Now I made a note that they do give you the volume formula for a sphere on the EOC reference sheet, but y'all don't need to worry about that because you won't be taking the EOC. But this is the volume formula. Let's look at it. It is 4/3 pi r cubed. So you don't square the radius like for area and surface area, you actually cube the radius, multiply it by itself 3 times. So you cube the radius, multiply by pi, and then take 4/3 of that. Now, speaking of 4/3, there's a couple different ways you can find 4/3 of something. If you're using a calculator, the easiest way is just to multiply by 4 the numerator, and then divide by 3 the denominator. That will give you 4/3 of a number, okay? You can also multiply by the decimal equivalent. Now, 4/3 is 1 1/3. 1/3 is repeating. So it's 1.3 repeating. Usually you can't enter repeating numbers into a calculator. You may or may not. So if you're going to use the decimal equivalent to multiply by, I would use several 3s. I would use at least 3 3s to keep accuracy in your answer. And remember, and since you're cubing the radius, a lot of times your numbers get really big when you're dealing with volume of a sphere. So I would use at least, or multiply by at least 1.333 to find 4/3 of a number. So to find 4/3, either times by 4 and then divide by 3, or multiply by 1.333. Okay, either way is fine. All right, let's go ahead and do some examples. Now, I've looked at your homework problems from the book, and it specifies to round your answers to the nearest 10th, 0.1. So what we'll do in our examples is we will go ahead and instead of keeping the pi symbol at the end in terms of pi, at the very end we'll go ahead and multiply by 3.14 and approximate our answer. All right, so number one, we simply just have to find the volume. I'm sorry, it says find the surface area rather. So we bring up our formula for pi r squared. So we're going to do 4 times 3.14. We'll see the radius is simply 5. So this is 25 times 4, which is 100. And 100 times 3.14 actually just moves the decimal over twice. It's still an approximation though, remember. So 314. And remember, surface area is square inches, so inches squared or square inches. And there you go. Surface area of a sphere with radius 5. All right, let's hop to the back. All right, number 2, we're going to find the volume of the sphere. And be careful, because sometimes they'll give the diameter. Don't use diameter. You got to use the radius for a sphere. So radius, chop that in half to get 4.5. And volume formula, let's bring that up. It is 4/3. And I guess since we're just multiplying everything and rounding anyway, let's just go ahead and use the decimal equivalent of 4/3. You don't have to, but we can if we want. So this is 4/3, and then pi, so 3.14, since we have to round anyway. And then radius cubed, 4.5 cubed. All right, now 4.5, if you cube that, raise it to the 3rd power, you get 91.125. And we're going to multiply that by 3.14 and times 1.333. And if we punch that all into the calculator, the final product is about 381.4 if we go to the nearest 10th like they're going to want you to do in the book. Now it's volume. Volume is cubic feet or feet cubed, cubic inches, or I'm sorry, cubic units or units cubed. So we're going to do 381.4 feet cubed for our volume. Okay, let's go to number 3. All right, number 3, we're switching back over to surface area, and they're going to do this on your homework. They're going to, rotate you between some surface area, some volumes to make sure that you're using the correct formula based on what they want you to find. Okay, so surface area of a hemisphere. Well, the surface area formula for a normal full sphere is 4 pi r squared. So you can do this one of two ways. You can find the normal surface area by using the formula and then divide by 2 at the end. Or, since you know it's a hemisphere, half of 4 is 2. So if you want, you can just use 2 pi r squared since it's a hemisphere. It really doesn't matter, okay? So either do the full surface area and then divide by 2, chop in half at the end for a hemisphere, or you can just divide the 4 by 2 at the start and use 2 pi r squared. Let's just keep this one, I guess. Radius 20, so we pop that in. 20 squared, which is 400. We're still rounding, so 3.14 for pi. And 2 for a hemisphere. This is 6.28, I know, when you multiply. So it looks like our answer should be 6.28 times 400. So if we multiply that, the product is 2,512. You do get a whole number, but again, it is an approximation, and it is surface area, so square meters. Okay? Now, one thing I do want to mention real quick before we finish up with 4 and 5. A hemisphere is half of a sphere, okay? So if you were going to draw one, like if you chop off the top half, you basically have a bowl shape left over. So that could be like a bowl-looking shape, like a hemisphere. Now, take like a basketball or, some type of hollowed inflatable ball. If you slice it, let's say it doesn't deflate. If you open it up, it's probably going to be hollow inside, that's where air would be. So a lot of times if you have a hemisphere, depending on the context of the word problem or the nature of the word problem, you may or may not have an open hemisphere. Basically, is it covered or not? Because some hemispheres that are half of a sphere may be open, or they might have an actual cover. Well, if you have a cover or a lid, or if it's closed up, you have more surface area. If you just chop a sphere in half and it's open, it's half of the formula, half of the surface area, or half of a normal volume. Well, actually not, the volume doesn't matter, but back to the surface area. So basically, pay attention to hemisphere problems. If they tell you that it has a covering, that means you have more or additional surface area. So you have to add something back to the 2 pi r squared. So if it's covered, if you have a covering, you have to add the shape of that covering, which is a circle. So you have to add back a pi r squared, okay? You're not going to run into this too often in problems, but some word problems that do talk about hemispheres, pay attention, see if the hemisphere has a cover, if it's fully enclosed. If it is, you can still use 2 pi r squared, just add another 3 pi r squared, add another pi r squared, which I just had a Freudian slip, actually pops up to 3 pi r squared. So just a little side note about hemisphere surface area. Okay, on to number 4. I talked about that long enough, huh? All right, number 4, find the surface area of a sphere if the circumference of the great circle is approximately 200. All right, so they don't give us a normal volume or diameter. They give us some information about the great circle, which is a normal 2-dimensional circle. So they give us the circumference of the great circle. Well, the circumference is pi d. So we're going to have to work backwards with the 200 for the circumference and figure out what the diameter or radius is, and then use that for the surface area, okay? So if we pop in 200 for circumference, pi 3.14, we can divide by 3.14 to find the diameter. So 200 divided by 3.14 gives us about 63.7. And if we chop that in half to get the radius, we get 31.85. Now, since we have the radius, we can go ahead and just straightforward use the surface area formula. It is a full sphere. So we're going to use 4 pi r squared. So 4 times 3.1 for the pi times the 31.85 squared. All right, so 31.85 squared It gives us 1014.4 approximately. 4 times 3.14 is 12.56. And if we multiply those two values together, and I guess we're still going to round to the nearest tenth, we get 12,740.9. And our unit was yards, surface area, so yards squared. Okay, so all you got to do is work backwards with the circumference given to find the radius, and then you can use the appropriate surface area formula for a sphere. All right, here we go. Last one, number 5. Find the volume of a hemisphere if the area of the great circle is 9 pi square centimeters. All right, so again, they give us info about the great circle, the area of it. So area pi r squared, we're going to work backwards to get the radius, and then we can use the volume formula and find the volume of the hemisphere. So 9 pi, we plug in for area. That equals pi r squared. Now the pi's are going to cancel. And you take the square root of 9, you can get 3. Square root both sides, because 3 squared is 9, so the radius is 3. All right, now we can just use the volume formula and chop it in half because it is a hemisphere. All right, so here we go. 4/3 pi r cubed. Again, if we want, you can times by 4, divide by 3, or since we're doing decimals anyway, I'm just going to use 1.333. Pi 3.14 times the radius cubed. Now, the radius cubed, 3 cubed is 27. So if we pop all of this, and we got to divide by 2, right? So that's the same as timesing by 0.5. So you can actually put all this into the calculator. Here is your normal volume. And since it's a hemisphere, we can just times by 0.5, which is the same as dividing by 2. And if we pop all of that in, 1.323 times 3.14 times 27 times 0.5, we get approximately 56.5. And our unit is centimeters, so centimeters cubed. All right, guys, that is 1 through 5, surface area volume of spheres. Now, a couple of things that I didn't put in the notes, but I do want to mention, for those of you who have stuck with me this long, some hints on some of the homework problems. All right, so on number 3 of them I want to mention, to just give you a hint on what to do. They might be a little bit trickier, I'm not sure, for some of y'all. Number 27 on your homework, okay? What you want to do on this one is you want to use the surface area formula and work backwards to find out or solve for r, the radius. And then once you find the radius, then you can use the volume formula to get the volume you need, okay? On number 31, I told you to only do part A, and in part A, only find the volume. To do this problem, this is a cone with a hemisphere stuck to the end of it, and they want you to find the volume. So all you have to do is add the cone volume to the hemisphere volume. Okay, so find the volume of each with the dimensions given and simply add them together to get that, what they call a composite shape. And on number 42 in your homework. Now on this one, and we've done some problems like this in the past in this chapter a little bit. They tell you that a certain dimension changes and they want you to know how it changes the volume or surface area. So in 42, they tell you that the radius gets quadrupled, multiplied by 4. And what does that do to the surface area and the volume? Well, to figure that out, you have to look at the formula. The surface area formula, in that surface area of a sphere formula, the radius gets squared. And in the volume formula for a sphere, the radius gets cubed. So you have to square and cube those numbers that the radius goes up by to get how the surface area and the volume both increase. So try that on 42. And that's it, guys. I will see you in a few days. Okay, bye-bye for now.